Okay, so in this video, we're still in section 5.3. We're still working with factoring, but it says find the zeros. So we have a new vocab word. Zeros are equal to x-intercepts most of the time. There's certain cases where they're something slightly different. We'll get into that later. But basically, it's what makes the equation equal to 0. Well, think about what we've been doing. We've been factoring and setting it equal to 0. So what x value makes this guy equal to 0? So we have h of x. So we have some function. This guy is the same as y. So what we're going to do is we're going to set the equation equal to 0 and solve. And we should see that this is a difference of two squares. There's a couple different ways to solve this. But with what we know right now, we have a perfect square here and a perfect square here. The square root of x to the fourth is x squared. The square root of 16 is 4. So I separate it as x squared minus 4, x squared plus 4. Now I look at what I have here. That's supposed to be a plus. This guy I cannot factor anymore, but this guy I can. So x squared minus 4 is another difference of squares. So I have x minus 2, x plus 2, and x squared plus 4. So I'm going to go ahead and I'm going to set this equation equal to 0. And because I have three of these, the product property still applies. I have x minus 2 is equal to 0, x plus 2 is equal to 0, and x squared plus 4 is equal to 0. I move everything over. This guy is a negative 4, and when we take the square root, we're told that we cannot do that. We're going to get imaginary values. For the time being, we're going to ignore this solution. So right now, the zeros of my function are 2 and negative 2. Now, these guys, plug them back in, it will cause this guy to equal 0. We can do that as a real quick check. X to the fourth minus 16, and I plug in a 2, that ends up being 16 minus 16. What makes the equation equal to 0? That's why it's called a 0. And if we plugged in negative 2, we get the same situation. Same idea. What we're doing is we're going to go ahead and set it equal to 0 and factor. But one thing I want you to notice is every single one of these guys, we do have a common factor of 2. So if we divide everything by 2, so we're going to set this equal to 0. And because it's equal to 0, if I divide both sides by 2 algebraically, not causing any problems, now it's much easier to work with. So I multiply the 3 and negative 8 together, and I get a negative 24. What two numbers multiply to negative 24 but also add to a positive 10? That would be a positive 12 and a negative 2. So I'm going to split this into 3x squared plus 12x minus 2x minus 8. Group, so I'm going to split it down the middle. The greatest common factor on the left side is 3x. I'm left with an x plus 4. Negative 2 on the other side, which also leaves me with an x plus 4. And now I put my outside groups together and my inside together. That's equal to 0 from the beginning. Okay, so I just rewrite that down there. I set each term equal to 0. And solve. So I get 2/3, and x is equal to negative 4. And those are the zeros. So if I take these guys and plug them back in, it's going to equal 0. It doesn't matter which one I plug it into. I can plug it into this one right here, the reduced term, or I can plug it in the original. It will still equal 0. Okay?